All right, so the presentation this time around is going to be on, it's a developer focused thing and it's on performance tuning. And we've actually had some conversations about this in the last, actually, I guess since we've started these, we've had a lot of different conversations on just like some, best practices and generally what are some things to think about in writing better code, writing faster code, in also just addressing those situations where the code is running not to the level it needs to be. In some cases, it's like horribly bad, so as to be unusable, where maybe there's a query that you're running that takes days and it really needs to take seconds or minutes at most. Or it may be something that's not quite so bad, where, as we talked about a lot in the early days, maybe where you've got a website, a web page that's coming up and you want it to come up in 2 seconds, but it's taken 2.5 or 3 seconds to come up, something like that. So there's really two focuses on this. One is making usable code, actually performance tuning to a level that your code is actually useful. But then there's also the idea of getting into some good habits so that your code, just generally speaking, is going to run pretty tight, pretty quick. You're not going to have to worry then as much about things like timeouts and memory issues and stuff of that nature. And so we're going to look at, these are the things we're going to talk about, and look at some best practices and just some considerations in general. This really shouldn't be different depending on whether you're doing, say, Java or C# or Ruby or like scripting, like bash scripting or HTML or JavaScript, whatever. This should be able to apply just about every situation. We're going to talk about the difference between bad versus okay versus good versus great as far as performance and some of the things you may want to think about. Talk about some common pitfalls related to flow, related to logic, the curse of complexity we've actually covered several times, and just how that can trip you up. Some things to think about with memories and loops, and then tools and assistance in helping you get better. So good, better, great, crappy, however you want to evaluate your code. Well, there's some things to think about in doing this. One is a minimum viable product, or getting the bare minimum to just get something done, to just solve a problem. Brute force approaches. This is often what we run into when we're doing, maybe research or something that's new, that we're not really sure how we're going to get this thing done. So we just want to just code it up. This may be the first time you're learning a language, first time you're working with a particular API, the first time you're working with a particular data set. And that's like your first step usually. It's not quite a hello world type of an approach, but it's just I just want to get this thing, I want to find a solution to this problem. And then from there, you're going to progress to, okay, well, let's clean it up a little bit. I've got the brute force approach, but maybe I can make it a little more readable, maybe make it flow a little bit better. And then from there, you're going to typically you're going to have sort of a review or something like that, of personal kind of thing, where you're just looking through and just trying to avoid common errors. And this is where we start getting into the idea of being a better developer and having habits and best practices that just become part of how we write code. And then the next step up in level of quality essentially is where you've got some sort of a design and review approach that's beyond just you, where you've spent a little bit of time thinking about it. You're not just solving the problem. You've actually thought about, now with that solution, how can I maybe design that a little better? How can I make my loops a little tighter? How can I have less data that I touch at a given time? How can I make this thing less of an impact on an existing system? And then also there's going to be some review there, whether it's yourself or somebody else in a team, another set of eyes looking at the solution and making sure that it's helping you find the best approach to there. Maybe throwing some additional ideas out, saying, hey, have you thought about this? Have you tried that? And then when you get to the best kind of approach, you're going to have spent some time designing it. You've evaluated the design. You've looked at the code. You've made sure that the code is following that design. And then usually even after you've done it the first time, it's almost like a rough draft of code. And then you're going to come back and you've spent some time really refining the code in that process. When we get into the general kind of coding that we're doing, and we're usually not going to have enough time or have enough desire to get to that top level. But when you think about things like commercial products, sometimes our side hustles, I know Michael's done a lot of that kind of stuff. We've talked about his testing tool. We've talked about, well, how do we design this? What's the best approach to this? What's the best way to do this, solve this problem? And that's where you're talking about that highest level, trying to get every cycle of the processor to get the most out of it. So then we've talked about sort of those levels. Well, let's look at some common things that we want to think about when we're doing this evaluation and reviewing our code. The first thing is with flow. One of the things you'll see a lot is that it ends too soon, is that you have something where, and this sort of combines with the next bullet there of an extra loop, where you flow through and part of your you've solved the problem, but not thoroughly, that maybe you haven't followed through and taken that last step, or maybe you haven't really thought through the complete solution. So you've gotten to an answer, but then you don't realize that, oh, wait, there is a little bit more that needs to be done to actually solve this problem. It may be as simple as you get an answer, but you don't actually send it back properly to the calling function or user, or maybe you don't output it properly, or maybe you don't send it back to whoever needs to work with it properly. You'll see that a lot with flow, where it's like, oh, okay, I got this thing done, and you were so focused on the problem, you forget that there is other stuff going on. There's a context to that problem. And so that's usually what you need to do is figure it out that, okay, I've solved the problem, but now let's make sure that my inputs are properly, I've looked at this in the context of, okay, how do I get input, and am I giving a proper formatted output? Another flow pitfall you'll see a lot is inaccessible code. Is that you in here, you're solving this problem, but somewhere along the way, while you were tweaking code and making some changes, that you actually created some code somewhere that it will never actually reach there through logic or certain types of data. You got code that just, between if statements or loops or anything like that, it just will never actually get to that. Maybe you return too soon. Those kinds of things are very common flow pitfalls, particularly if you sort of started with a solution and now you've been tweaking it a bunch, or somebody else started with it and you've had to go in and maintain their code. You'll have these kind of situations where you set a couple values, the next thing you know, it's like, oh, wait, I'm not going to be able to get to that code. I see it a lot where it'll be stuff like, maybe an if statement says if not null, and then you'll see right above that a line of code that sets that value to null. It's like, whoa, wait a minute, I need to think about that a little bit more. And this will happen a lot also when you're simplifying code. I see that happen quite a bit, so you have to be very cognizant that could happen. Another flow pitfall we see quite a bit will be multiple paths through the solution that have there's a couple different ways it can go, and you can either confuse the code, or it's almost random which path it takes, which solution gets done. Sometimes we'll see that where you've got let's say if less than 1 and if greater than 1 are two different ways that you're, two different paths through the solution. Well, what happens when the value is 1? Sometimes that sort of falls through and misses it completely. Or sometimes you'll have overlap where you'll have, if less than equal to 1, if greater than equal to 1, and it's just a matter of which section of code does it hit first. So when you're looking at your flow, particularly anywhere that there's branches, make sure that those branches are mutually exclusive if they need to be. And another one we see a lot in common flows is you used to see this as a beginner programmer. I think you see this quite a bit where you'll get an infinite loop. But even as an advanced programmer, senior programmer, sometimes you'll just you have a brain fart basically. And essentially you got a loop where you don't have an increment or a decrement within that loop. So the loop just goes on forever. You forget that, oh yeah, I've got to actually move a value so that it will, do the next loop. Or sometimes they don't, you don't exit cleanly out of a loop is sort of related to that, where there's like a break or a value that you're looking for. So you're looping through, let's say a collection. And as soon as you find a certain value, well, you bail out. You say, all right, well, I found that value. Now I want to move forward. Well, sometimes you've got some additional resources or other things going on that you can't just bail out. You have to actually sort of clean up after yourself a little bit before you get out of that loop. Moving on to the logic kinds of pitfalls, which, again, there's sort of some overlap between looping and logic, because usually there's some sort of logic that tells you when to loop and when to complete the loop. Very often with a lot of languages, and now there's a lot of stuff, IDEs will even help you with this, is equals versus assignment. This is in, like, say, a PHP or a Java world where you have an equals versus an equals equals, or in some cases an equals equals equals, whether you have 1, 2, or 3 equals symbols together is different. In one case, it's essentially setting a value to be a value, setting a variable to be a value. And others, it is a Boolean, is this equal? Are these two things equal? Do they equate to each other? And even within that is what does equals means between, and what does that mean between two values, between two variables? Because depending on what your language is and how it works, it may be that, does that mean that those two variables are the exact same pointer to the exact same memory? Or it may be, are those two values variables pointing to things that have these same values, so that the pointers may be different, but the value underneath them is the same. And of course, when you get to classes and objects, what makes an address class equal to, or let's say object equal to another address object? Is it based on the street name? Is it based on the zip code? Is it based on the state? Is it based on all of the above? So comparison becomes often an issue and a logical flaw that you'll find, particularly as you get into complex data structures. The next one, off by one, for myself personally, I think it is the error logic pitfall that I have hit more often than anything else in my career as a developer. And it may be a personal thing, but I also, because of that, that's one of the first things I look for when I'm reviewing somebody else's code. And it does seem to be very common. It's just really easy for us to forget that, we want to do, let's say, less than equals to instead of just less than. Or we're counting through a loop and we forget that we need to start at 0 instead of 1, or vice versa. And we need to end at the end as opposed to one beyond the end of our collection or one before our collection. Happens all the time. So it's usually that's one of those that you should get in the habit of just checking that if something doesn't seem quite right. And with testing, you really need to check that, because it's very often that everything will work fine, but it'll miss that last item in the collection. And so it works, but it ends up getting, your numbers are off, and it's because you're off by one. Complex Boolean logic, and particularly negating it, this is where, it's just part of the struggle of being a developer, I think, is you start getting into something where it's this and that, or that other thing, and maybe this in some cases, but not that, this very complex logic, it can be very easy to get in there and screw stuff up and have things that don't work quite right, particularly if you've got a series of like if then else statements and you've got very complex logic each step of the way. It's very easy to get that stuff off. So make sure that you walk through it and you really, slowly pay attention to what is this logic actually testing to make sure that it's correct. Similar to unreachable code, sometimes I'll find stuff in there where there's a whole bunch of code dealing with something that the user can never actually get into that state. There's whether it's validations before you get into a function call, or it's sort of related to that complex Boolean logic. It may be that the user or the system itself can't actually ever get into that state. So you may have a whole lot of code that essentially gets skipped, or you've got something that you're trying to get to, and you somewhere along the way have blocked the system from being able to be in that state. And so you end up, it's either dead code, useless code, or sometimes you end up sort of blocked as it gets to a certain point and it's waiting for something, essentially an infinite loop. It's waiting for a state that can never be achieved. Resource usage and black boxes are also, it seems like languages have tried to make this a little easier. The resource usage in particular, the memory management headaches that you had to deal with C and C++, and they're sort of going away when you look at like C# and Java. They've got their garbage collection and things like that. However, and PHP sort of the same way, is they sort of take that stuff away, but not really. You still need to think about particularly like resources that are not management, like files and things of that nature. If you open a file, somewhere along the way, you need to make sure you close the connection to that file. Or a database. If you open a database connection, somewhere along the way, you should be closing that database connection. It's real easy to forget about that, particularly if you have like say a series of code where you're calling all of these methods or functions within that series of code, and you start at the beginning and you open the database connection, let's say, and you do a bunch of processing, and then somewhere along the way, you're hoping that you close it. But all of these things that you're dealing with are assuming maybe that the connection is open, and maybe even they check and say, hey, if the connection's not open, let's open it. Well, if you don't have the right logic on that, the right sort of master logic or top level logic, you may never actually get that connection closed. And suddenly you can have all kinds of orphan things going around, and you can bring a system to its knees actually fairly quickly doing that if you don't watch out, particularly file manipulation stuff. If you're going through and you're processing a directory of files and you're opening all these things, but you're not closing them, you can run into problems very quickly. Now, the black boxes part of this is where sometimes we trust the code we're calling a little too much. And so you'll go in and you'll say, hey, this is sort of like this thing. I'm going to open a file and I'm going to send out the data to this black box, whether it's an API or some other class or function or procedure or whatever that's going on. And then I'm assuming that when I get done, that the file will still be open and I can close the file afterwards. Or maybe I assume that the black box is going to close the file properly, or open and close the file properly. There's some things like that we make assumptions, but those are not always correct. So we need to be very clear and educated on what we're using, particularly if it's a framework, a library, an API, or some other essentially black box where we're calling something and we're assuming that certain things are being returned or state is handled properly. Related to that are side effects. Sometimes if we're using a library or framework, hopefully side effects are not going to be as much of an issue because they hopefully were designed properly. But particularly when we do our own stuff, sometimes we get a little lazy. We're doing something sort of a quick fix or something like that, and there's some sort of a side effect where we say, oh yeah, we're going to assume that there's a certain state that we're in, and that the code is in a certain state, and we can go do these couple of extra things to save us some work to make the design a little simpler and easier. Well, those side effects can cause all kinds of problems. So make sure that you properly document any of those kinds of things, that you've probably handled those things, and ideally that you're not actually doing that. Whatever is sent in is not changed, and you change stuff through return values, things of that nature. With classes and objects, it becomes real easy to have a lot of side effects where you're beneath the covers doing a lot of setting some switches, setting some values, cleaning some stuff up, things like that. Make sure you document them, and if going through and doing a code review, make sure you clearly understand what is being done. The curse of complexity. This is something that we have had a lot of conversations about, particularly little side conversations over the years of, hey, I'm building this thing. Does this seem right? Am I overthinking this? Or I've got this thing going on and I can't find a bug. And you look at it, you say, wow, why are you doing all of that? It's not that complex. You should be able to do a more direct line to get from point A to point B. And this occurs for a lot of reasons. One of it is just the idea of duct taping, using duct tape and baling wire to add on to your application. You see this a lot, not necessarily in our side projects, although sometimes we do, but more often where you end up in a project for an employer or a customer where you've built a version and put it out there and spent some time with it, but now there's bug fixes, there's these quick little enhancements, quick in quotes, basically, and little changes that are made, particularly in an agile environment where you do sprint after sprint after sprint, and you're adding features and doing enhancements, and you're never actually going back and doing a review and fixing the problems and redesigning the things where you've tacked all this stuff on, and now you really need to look at redesigning a piece of that solution because all of these features that were tacked on were not really taken into account in the original design. Thus, you have technical debt. Well, if you go too far without addressing that technical debt to some level, then you're going to end up with something so incredibly complex that it becomes a complete pain in the butt to debug and deal with, and any kinds of problems occur. Another one we find a lot is a cool feature of a language. We find something that's like, oh, look at this new feature, I want to take advantage of it. And the next thing you know, you've got this really complex solution where it didn't need to be. The only reason it's complex is because that allows you to take advantage of this new feature that doesn't really add value to your solution, which is sort of the same way as the Cadillac versus the bicycle approach. Sometimes either through our over exuberance or a vendor or something like that, somebody comes in and builds this just really cool, incredible solution to problems that don't exist yet. Sometimes a customer don't need this big Cadillac, high-end, heavily architected, highly designed solution. They just need something very simple that's roughly a spreadsheet or data entry on a couple of forms and one simple report. That's sometimes we make things more than they need to be. Related to all of this is really a little bit of showing off. Sometimes you'll see that whether we're doing it for our boss or somebody like that, or we'll come across somebody else that's trying to basically justify their existence, or something like that, where it's just, you get something that's just overly thought, over architected because somebody's trying to prove a point or show off their skills. Timothy mentioned a couple meetings back, a YouTube channel where this guy was, basically he was laying out some anti-patterns and talking about how to create incredibly obfuscated variable names and stuff like that. And those are kinds of things that, you can do it, and maybe a little job security behind it as well. But at the end of the day, that doesn't help anything, and usually is going to make the code run slower and be more problematic in general. It's not really a complexity thing, but really it falls along those lines. It's sort of overthinking a problem sometimes, is the idea of magic numbers. And this is prevalent in so many situations, it's almost scary, is where you're looking through code and somebody's looks to see, there's some check in there that says, oh, if value equals 3, then do this. If value equals 4, do this other thing. And what they've done most likely is they've hard coded something, whether it's a status value or some sort of state or some sort of answer to some algorithm. They've gone in there and they've just hard coded all that stuff, which is sometimes sort of nice as far as a performance point of view, but from a maintenance point of view, it becomes a complete nightmare. And sometimes those magic numbers are only valid for a certain period of time. As you expand the solution, going back to that first idea of enhancements and addressing technical debt, sometimes what you end up doing is you've got that magic number, those magic values end up taking you down a path that you really don't need to go down. Sometimes you've got those things initially because of that brute force solution, but you need to clean it up a little bit so that it's maintainable. But also, sometimes it's so that you're actually always taking the right logical path through the solution. So in addressing that complexity, you laid out all these problems. Well, what are some things that we can do to fix that? Well, code reviews are always going to be your best way to look at it. You get a team, even if it's 2 or 3 other people take a look at the code, they're going to look at it and say, okay, that seems to be overly complex. That seems to be more trouble than it's worth, because they've got to, to review it, they've got to understand it to some level. And if it's driving them nuts doing so, then they're going to say, hey, this, you've gone too far. Regular improvement cycles, which is basically addressing technical debt as it occurs. Somewhere along the way, whether it's a special sprint that's really just a technical debt sprint, or with any given sprint where you take a little bit of time and you go back and you look at improving some of the code that's already been created, or as if you're more waterfall and you're doing versions, then you should have maybe fixed releases along the way, or some percentage of any each version release is, let's go back and look at what we have and tighten up and improve and simplify the solutions that we have. You can do a rough draft of code and sort of consider that that's, again, back to that idea of, okay, I've solved the problem, but then somewhere along the way, you want to do a pass where it's, okay, let's take a look at what we've got and see if we can simplify. Maybe we can shorten some stuff here. We can drop a few cycles or some loops there. Maybe there's some additional computations that we can either hardwire or we can extract those out, so those can be made easier to read and easier for the system to produce, to actually solve. In this case, you're thinking about it as far as simplifying the algorithm. Think about with a database, if you're working through, or actually any collection where you're working through and trying to find an item or a set of items, a subset of items within some big collection. Well, the ways that you slice and dice that collection to get it down to what you're looking for are going to allow you to, more quickly process it. The easiest example of this is to look at how all of the different types of sorts address sorting the objects, within the collection. Some of them are very, like a bubble sort is very brute force and simple and easy to code, but not very fast. But then you get to some of the others where they really find a way to get down to the nitty gritty of sorting the collection. But code wise, maybe it's a little more complex. Maybe it has to do some sort of logic that's just doesn't like jump right out to you, doing some sort of regression across the sets and stuff like that. The biggest thing you do is just think about it before you actually adopt a framework, a library, or some approach. It's almost an anti-pattern, is that sometimes we'll look at stuff and say, oh, well, this is the approach I need to take. And maybe it's not. Maybe that approach worked the 3 other times you use this, but now this problem is just a little different, and what you're doing is actually over-architecting the solution. I see this a lot in frameworks and libraries where they've built out this solution that's got all of these, this big complex hierarchy and all of these things that are built, all these little structures to keep everything very dynamic and easy to change. But maybe that isn't required for your solution. So maybe all of that flexibility built into the solution is not needed, where you can throw it away and you can do a much more, we'll say, static kind of solution that works perfect for the situation you're in. And along those same lines is fully complying with the practices of a framework or a library, or how typically the best practices even of a solution may not always be necessary. There may be times that there are things that considerations that aren't needed. Think about as a simple example, whether your solution needs to support different database vendors. Do you need to support MySQL and SQL Server and Oracle, or do you really only need to support SQL Server? Well, there may be some best practices that would allow you to easily change, and point your solution to all these different databases. But that's extra overhead you don't need if you know that you're only using one database ever. That should often be a question that you ask your boss, your manager, your customer is, how dynamic does this solution need to be? Is this situation something that we are always going to see or sometimes going to see? What are the variables that we need to worry about? Because if you reduce variables, you reduce complexity. Always an easy way to look at that problem, at that, however you're trying to create a solution.
Hey, Rob.
Yeah.
Can you go back a second?
Yeah.
So I don't mean to interject in the middle, but it just kind of want to add to that. So when you're talking about the database and not adding multiple databases for complexity, if you actually wrote your database connection method or function correctly, if you set it to where it would pass in the driver information, you really, basically, you don't have to overcomplex it. You just keep it where, okay, I'm passing it now. I don't have to add that logic later, but it's already set up that I could expand it later.
Well, and that's sort of where it runs into.
Because you could keep it simple and just make a note to expand it later. You just have to write a secondary function, but you can still set the initial function up enough that it can be configured. It can be extensible later. You don't have to build that out, but you can at least set it up correctly, because really your functions and method calls, your parameters are going to should drive what it does.
To some extent, but this is where sometimes you can go in and you can, there are situations where you're going to be better off from a performance point of view to just go ahead and hardwire your approach. You don't have to actually design for extensibility if you're never going to extend it. And that can allow you to get a little more of a performance boost, to include things in and it's one of those where there's a little bit of a balance. You don't want to code yourself into a corner, but if you know that that you never need to get out of that corner, then you can do so. If that makes sense, is that there's times where, this is again where that full compliance is not always necessary. There's things we get ourselves into a habit of doing, and in particular layers of abstraction and approaches to like object-oriented that we don't really need. For example, there's a lot of arguments out there, discussions around getters and setters. Do you always need to have getters and setters? Does that, if you go back to object-oriented basics, yeah, you would have that data abstraction. So you'll have private properties, and then the way you access them is through getters and setters. Well, that's not the fastest way to get stuff done. It'd be better to be able to directly access those variables. But that also has its downside. That takes away some of your flexibility. But on the other side, if you don't need that flexibility, then you can go right ahead and do it. You don't need all of that extra layer of abstraction if you're never going to extend it that way. You can see that a lot in if you look at like data models. Sometimes you've got like particularly like object relational model kind of mapping, where you've got a data object, and then you've got basically an interface to deal with that, and then you've got an implementation of the interface, which if you're never going to extend that stuff, then you may be able to go directly into the implementation of it. Maybe you don't need that interface layer. So it's, this is where you start getting into, look at the solution itself, and yeah, you're going to limit your ability to tweak that design, but maybe you don't, that's okay, because maybe you're never going to tweak it in that specific way, and you're going to be able to go in and actually effectively, it's kind of like hard coding part of that solution, and say, well, I don't need to be compliant with this being the best practice or the right way to do it, in quotes, because that becomes, that's not a consideration for me. I really need to deal with this other piece instead. And so from a performance point of view, it almost becomes questioning some of those best practices and saying, do I really need to do this? Or am I doing this because that's just generally speaking, that's the best way to go. And I'm solving for the general case when instead I really should be solving for a specific case, if that makes sense.
Yeah, it does.
So moving along. Good question, though. Good point.
Yeah, because like the getters and setters thing, if you think about it, though, the whole point of the getters and setters is so that you don't potentially have one. If you're passing the object around, you don't want one method updating a value where another one's reading it before it should read it. So that is just something you got to watch, I guess, overall. But I understand what you're saying.
Yeah, and that's where you run into these where you got to watch out. There's risk involved in not doing it. Again, you could code yourself in a corner. There's some risks that can be involved, but sometimes for performance, you need to say, well, this isn't a risk because I control enough of the variables in the environment that this is something I don't have to worry about. When you think about it, it's like certain checking for exceptions. Sometimes you can look at it and say, well, there's 15 different exceptions that could occur, but there's really only 2 that I could ever run into. So I'm just going to worry about those 2. I'm not going to worry about all these others because that's just overhead I don't need to worry about. So it's things like that where we get into these habits of following a certain line of coding, and sometimes that's not going to give us the fastest, tightest solution. And so it does sort of fight against best practices and flexibility, and even sometimes maintainability versus I need to get to the solution as fast as possible. And it's where and again, it goes back to, even the idea of object-oriented versus functional programming and bare metal programming, you're making different trade-offs. And so moving into memory and loops, sort of talked about this already, but whatever you open, close it. If you declare it, there should be some place where you undeclare it, or you free the memory, or you set it back to null, or whatever you need to do so that it gets garbage collected properly. If you open a file so that it doesn't stay open longer than it needs to be. If you open a database connection, or you pull a query that locks records, that you minimize the amount of time that you actually have that stuff open, so that you're, 1, not having to use that resource more than you need to, and 2, so that if there's something else that needs to use that resource, it isn't blocked from doing so. Simplify loops wherever possible. This is a big thing that we run into if you're trying to improve performance of your code. Don't do stuff in a loop that you don't need to do. And that even includes declaring variables and setting default values and stuff like that. If you can do that stuff outside of the loop, then do so. Make your loops as tight as you possibly can. Put as little code as possible into the loop. And with databases, this becomes a challenge sometimes because we will write code that's going out and pulls a query, and it's cycling through that query and doing some work on it. And so we've got that query open for that entire life of the loop. We've got all kinds of stuff going on. Sometimes you may even want to look at it and say, well, maybe instead of doing all that processing, I'm going to pull a lot of data into memory, release that query, essentially that result set back to the database, process the data, and then go back and maybe reopen that query, things like that. So when in doubt, really pay attention to your loops, because those most likely are going to be where you're going to have the biggest impact to performance. And
a quick question there. I don't know if you have a database piece on here, but one other thing to think about: if you don't need to move your queries to the middle tier, and you're only going to have one database, consider moving the queries to stored procedures if they take too long. That moves a lot of the overhead out of your application and can speed things up.
Yep. Yeah, definitely. And do the above, even if it's annoying or requires some weird declarations. You see this a lot in file and database related stuff where you want to declare, like if you're doing a prepared statement, you want to actually declare that prepared statement value as close to where it's being used as possible. But sometimes it makes more sense to pull that outside of a loop, because you want to be able to control when that thing is open and when it's closed. Database connections, you see this a lot, where you don't want to actually declare that connection with inside the loop. You want to push it a little further out, so that with like exceptions handling and stuff like that, to make sure that if something goes wrong, that you can properly close that variable, as opposed to it falling out of scope. And now you're trying to handle an exception, but that variable that you need to access is no longer in scope, so you can't really access it. So sometimes you get some weird declarations. Java is a good example where they have changed some of their exception handling. So they've got like a try with resources that does make that stuff a little more, it's a little easier to maintain, because it now says, okay, I'm doing a try catch block, but I'm declaring that these are the resources that I'm using while I'm within this little try catch system. And I want to make sure then that I can get those things properly closed out, so that I can do a try catch and finally and have the right scope of access to those resources. Next one, similar, this really starts getting into what Michael was talking about, is store or use only what you need. You want to be able to, if you're looping on something, the resources that you're using, you want those to be as close to that resource as possible. So you want to be able to, you don't want to have like a file open for a long period of time and be, wheeling and dealing through every line of the file and doing a whole lot of work on it. You want to open it, get the data that you need to deal with, and then close it as fast as possible. With a database, ideally, if you can use stored procedures, that it is always going to be faster to use a stored procedure than it is to pull that data out and wheel and deal with it and then push it back into the database, or even just pull it out and wheel and deal with it. You're going to be better off if you can use the strength of whatever it is that you're dealing with. So in a database, its strength is sorting and filtering and mass updates and edits of data. Use it for that. And if you can, if you can push stuff in a store procedure, then by all means do so. Don't add additional, and particularly with database queries are another good example. Don't pull everything back if you don't need it. If you've got 15 columns, but you're really only going to deal with 2, just pull the 2 back. Don't pull all 15 back. There's no need to flood the network pipe with that additional data. It may not cost much on the database end, but as far as memory that it's going to consume, and especially on the calling side, that result set's going to be multiple times bigger if you have all of those larger values that are being pulled back. Do that as well with when you think about file processing. Sometimes you get into this habit of like, okay, I've got to I'm going to grab every line of every file and do all this manipulation, do all this kind of stuff, but you may not. Maybe you don't have to do it line by line. Maybe you can go in. It may be easier, but maybe it's faster to go in and do, essentially consider it like a fixed width kind of thing. So it's just going to go through and you pull only a couple of values and then just go to the next line, go to the next line, go to the next line. Don't pull. You may not have to deal with the whole line of code. You may only have to deal with a value or two within it, one token or not. And then with all this, you got to keep in mind types and storage. Databases are perfect for this. Is that you want to store a number, then store it as an integer. Don't store it as a string that's going to be up to however long that number can be. Like think about a zip code. It's faster if it's a 5-digit zip code. It's going to be faster if it's just an integer, because you can cover that there, versus it being a string of 5 characters. It's going to be, well, not faster, but it's going to be smaller, quite a bit smaller in that case. So think about what you're doing, about the data types you're using. Sometimes binaries versus large character sets. Variable size, if you use like in a database, the idea of a varchar versus a char, where it's going to dynamically assign space versus it's going to assign the maximum amount of space that it needs to hold that size. So think about what you're doing. Integers and floats, doubles, things like that. All those different number variations are very different in what they take up in size and how quick the system can manipulate them. So make sure you consider that when you're talking about your memories and your loop, how you loop through stuff. And that finally brings us to, we got all this stuff we're doing. Well, let's talk about some tools and some assistance that's out there from an automated point of view. Just about every language out there has got some sort of performance meter that you can put on it. There's going to be something out there, maybe free. Sometimes it can be costly depending on what your format, your language, your framework, your environment is. But there's usually something out there that you can use. Worst case, you can write your own, just some sort of a metric so that you can track how well your system is, your application is using its resources, and look for memory leaks and stuff like that. Your operating system's probably going to be able to provide that. So there should be some sort of a memory or operating system level tracking, logging status that you can check to make sure that things are performing as they should. Static code analysis tools are huge. A lot of the stuff that we've mentioned through all of this, the common kind of pitfalls, a lot of the static analysis tools out there will help you catch those, particularly the ones that are that are language based, like the equals versus the double equals, assignment versus equality, memory related stuff, dead code, complex structures that maybe don't make sense. Those kinds of things are all going to be often covered and caught and then pointed out to you through static analysis tools. So allow you to write, that alone can allow you to write a lot better code very quickly. The human element, get your team members, code reviews, extra set of eyes. Those are always going to help you write better performing code. If you run into a block of code that just doesn't seem quite right, ask somebody, coworker, buddy, whatever about it. And hopefully you'll get some good feedback. And sometimes it's going to be there's some simple, obvious thing that somebody else looks at it and they're like, hey, have you thought about this? And boom, you're off and running. And then having multiple test environments, development environment versus like a user or a staging, actual testing environment often is going to make a big difference, because developers' machines may be tweaked out a specific way that when you get into testing, staging, and then production, it's very different. You've got a different number of different loads, different number of users, different approaches. There's just a lot of things that are going to rear their ugly head, that if you want better performing code, you need to get to that sort of load testing type of environment. It's sort of a real versus just a more pristine bubble that you tend to live in as a developer. Get out there, let it do some real world examples, and then suddenly you'll sometimes be able to see real quickly that this is performing or not performing. So final thoughts. The best bet is always going to be design what you're doing first, and then just follow through on your design. Don't design it and then sort of toss it out, or not refer back to it. Test with reasonable and then heavy or peak loads, so that you can, that usually is going to bring out where there may be some performance issues. Always just check your off by one type errors. And as far as this is really almost more as we get into testing. So looking at one below and one above, whatever the maximum and the minimum values are within an expected range. Look for things like empty and full states. Database, there's a lot of times that going in the first time when there's no data in a table is going to break all kinds of stuff. But as soon as you put one record in there, everything's fine and running again. This again, often you'll see this developers environment. They've got a couple of records. They've got some things that have been pre-populated. You do your first install or a clean push to, say, the staging environment. Well, now you have some empty tables and suddenly stuff starts breaking all over the place. So, make sure you're checking those kinds of things just to make sure that you perform. It's not necessarily as much speed as it is just making sure that, this is removing bugs. When you run into a situation that, you created and that you need to fix it, well, learn from those mistakes. Take a little bit of note, do a little post-mortem essentially of, okay, well, what did I do wrong? And just put that in the back of your mind so that maybe the next time around that's a consideration, and you're not going to do it. That's just part of becoming better. That's part of experience is, hey, I tried it this way before and didn't work out so well, so I'm not going to do it that way. And that brings us to opening up for any questions or comments.
Yeah, other question? Mine during the presentation, sorry.
Oh, that's not a problem. Not a problem at all. So hearing nothing then, we'll move on to sort of wrap it up. So what do we learn? Well, the first thing is performance tuning your code it's just part of best practices. It's like everything else, getting into some good habits. Develop good habits, you're going to write better code. You've learned from your mistakes, you've learned from other people, you've learned from whatever your educational background is. These kinds of things, just sort of build that into how you write code, and you're going to get better at it. When in doubt, we talked about this a little bit, didn't refer to it as an 80-20 approach, but you don't have to be the best Cadillac solution to get the job done. We've talked in other ways that we've looked at coding and creating good solutions. Sometimes your 80-20 approach is going to be better. It's just get out there, get something that that solves a problem. Maybe doesn't solve it the best way, but is 80% of the way there of being a good solution. And then maybe that's all you need to do, and then you can move on to the next one, as opposed to spending more time and building this big, complex, super flexible, solves every problem in the world kind of approach. One size fits all just does not work in software very often. And finally, take advantage of the tools and other resources that are out there. You don't have to go it alone. No developer is an island. Talk to other people. Regularly take a look at what kinds of tools are out there to help developers, because there are some things out there that will make your life so much easier. Always, thanks a whole lot for your time, for listening through this, for following us. If you have any questions, comments, anything that comes to mind afterwards now, you can hit us up at info@developernoir.com. Contact us form out on the Developernoir site. Follow us on Twitter or send something there at Developernoir. Developernoir on Facebook. We're still out there, still putting posts out there on a regular enough basis. We'll take questions and comments there as well. As always, just thanks a lot to help us in our goal of making every developer better, and just pushing that ball forward every day. Go out there, have a good one.